So this is just a short video to go over the difference between standard and vertex form. So standard form, sometimes it's called general form. It follows the pattern y equals ax squared plus bx plus c. And what it tells you is, it tells you how fast the function's increasing by this a value. So if a is really big, the function's going to be steep. It's going to be a parabola that's super steep like that. But if this function, or if this a value is small, let's say like 0.5, it's going to be wider like this because it's going to be increasing slower. So just think, like lots of people think if this a value is small, it's going to be steep, and if this a value is big, it's going to be wide, right? Because they associate big with wide, and in math, it's actually the opposite because if this a, let's say it's like 10x squared, if your x is increasing to the right, so let's say this is your x-axis, this is your y, right? If your x-axis is moving to the right, right, x is or y is going to increase super quickly because as x gets bigger and bigger, it's going to be 10 times that bigger number squared, and it's going to go up super quickly. So standard or general form tells you how fast the function is increasing by this a value, and it also tells you the y-intercept. So remember our y-intercept, it's where it crosses the y-axis, and in this example, it's going to be right there. And if we look at it, our x value on our y-intercept is going to be 0 because it's along the y-axis where x is 0. So just think, if we plugged in 0 for x in these terms, all we're going to be left with is this last term because it doesn't have an x in it. So in standard or general form, the y-intercept, it's always going to be this last term here. It's going to be the constant. And if we go to our graph, that translates nicely because we can see at this point it is in fact -1. Okay, so standard form, it doesn't tell you right away what your roots are or where your vertex is. We can manipulate it, right? We know that there's a formula for the x-coordinate of the vertex to be -b over 2a, right? Where b is the -4 and a is the +2. That's going to be the x-coordinate of our vertex, and we can figure out what the roots are by factoring this. We could do factoring by grouping with the box method or whatever we do, but there's no inherent, like intrinsic way to figure out how this graph is going to look other than how steep it is and where the y-intercept is. Okay. Meanwhile, over here, this is called vertex form. So this is, notice, the exact same function, exact same equation. It's just written differently. So the vertex is the same at 1 and -3. Y-intercept is the same at -1, and it's increasing at the same rate with the same roots. So all these points are the same, all the function values are the same, except it's written in this form, y equals a, x minus, we write p squared plus q. Okay, and what this tells you is where the vertex is and how fast the function's increasing. So a in standard form and in vertex form is the exact same thing. It's the exact same value, right? It's 2 in this case. And in the other function, it was also 2. It just tells you that it's increasing twice as fast as a regular parabola x squared. So for every square you move over, it's going to be 2 times that change in x squared. Okay? So a is the same in that sense. P is going to be the x coordinate of your vertex, and Q is going to be the y coordinate of your vertex. So we're given, let's say we didn't know the vertex form. Let's say we only knew the general or standard form. We knew that the a value was 2. So the 2 is going to be on the outside. We know it's going to be x minus p. What's our p? Well, p is going to be the x coordinate of this vertex. So let's just go over here. We know it's going to be 1, because if I graph it in Desmos, the x coordinate is going to be the first number in this ordered pair, this coordinate. So it's going to be x minus 1 squared. And remember, the q is the y coordinate of a vertex. Let's just see here. If we go right here, that's going to be -3. So our q is -3. So this is our function in vertex form, and what do you know? That corresponds directly with the actual answer. So we can write any parabola in vertex or standard form. There's just something called completing the square that we have to do to go from standard or general form to vertex form. So you might want to convert it into vertex form for a myriad of different reasons. Like maybe you're trying to do an optimization problem with which I'll talk about in a future video, or maybe you're trying to figure out where a ball will hit its maximum height and start coming down, or whatever you need. Like the vertex is a super important feature of the graph of a parabola, and it could be beneficial to figure out a way to get it into vertex form. So that's the difference between the two. In the next video, I'll talk about completing the square, which is starting with standard form and going into vertex form. And then in the video right after that, I'll talk about optimization problems, which is just trying to utilize this form of a parabola. How to utilize when we know what the vertex of a parabola is, and how to use that to our advantage in terms of business or whatever else we're trying to do. So I hope this was helpful, and I'll see you soon.